Off-site construction is gaining popularity worldwide, offering a faster and often more cost-effective solution to traditional construction methods. Traditional construction often involves lengthy timelines, unpredictable costs, and significant amounts of on-site work, all of which can lead to inefficiencies and delays. In contrast, modular construction, where 2D and 3D modules are prefabricated in a factory setting and then transported to and assembled on-site, significantly reduces construction time and allows for better cost control. Modular construction can cut project timelines by 20 to 50% and reduce costs by up to 20%, making it a highly attractive option for modern building projects. Countries such as Norway, Sweden, and Finland are leading the way, producing approximately 45% of their buildings off-site. However, countries like Australia, the UK, and the US are lagging behind, with only 5%, and 3% of their buildings being constructed off-site respectively. The modular construction market is projected to grow into a $130 billion industry by 2030, underscoring the urgency of adopting these innovative building methods. In the modular construction space, one of the most critical decisions revolves around choosing between 2D and 3D prefabricated modules. These approaches differ significantly in their applications and benefits. In this video, we'll explore the differences between 2D and 3D modules, their advantages and disadvantages, and how they compare to traditional construction methods. By the end of this video, you'll have a clear understanding of which approach best suits your project needs. 2D modules refer to flat, prefabricated panels that serve as key structural or non-structural elements, such as floors, walls, and roofs. These modules are produced in controlled factory environments and then transported to the construction site, where they are assembled into the final structure. 3D modules, also known as volumetric units, are pre-assembled box-like structures that often represent complete rooms, such as bathrooms, kitchens, or even entire apartment units. Like 2D modules, they are constructed in controlled factory environments, transported to the construction site, and assembled into the final structure. While the process of factory production, transportation, and on-site assembly closely mirrors that of 2D modules, 3D modules arrive as largely finished modules, requiring minimal on-site work. When comparing 2D and 3D modules, several key factors come into play. Let's explore each in detail. First of all, we've got some project-specific factors such as the project size, type, and location. 2D modules are versatile, making them suitable for projects of all sizes and layouts. 3D modules excel in medium to large-scale projects with repetitive designs, such as apartment buildings or hotels. When it comes to project location, 2D modules' flat design allows for easy transport, making them ideal for a variety of project locations, including remote and urban settings. However, 3D modules require good infrastructure and access due to their larger volumetric nature. As for the other factors, let's begin by discussing material usage. 2D modules are highly efficient in material usage, as their flat panel design avoids redundancies like double walls and floors. In contrast, 3D modules tend to be less efficient due to these redundancies inherent in their volumetric design. Next, let's consider quality control. Both 2D and 3D modules benefit from being manufactured in factory-controlled environments, ensuring consistency and precision in the modules. However, 3D modules excel in this regard, as nearly all of the construction is completed off-site, leaving minimal finishing work for on-site assembly. While 2D modules also maintain good quality, The additional on-site assembly and finishing introduced more potential variability. Now, let's address design flexibility. 2D modules stand out in this area, as their flat panels are easy to customize and can accommodate irregular layouts and unique architectural designs. On the other hand, 3D modules are better suited for standardized and repetitive designs, offering limited flexibility for irregular layouts. Moving on to storage, 2D modules have a clear advantage due to their flat nature, which allows for compact stacking and efficient use of storage space. In comparison, 3D modules require significantly more storage space because of their larger, volumetric design, which includes empty spaces within. Let's now go over transportation. 2D modules are straightforward and cost-effective to transport, as their flat nature allows them to be stacked efficiently. In contrast, 3D modules are bulkier and more challenging to transport, as they occupy more space and include empty volumetric areas. They may also necessitate specialized logistical arrangements, adding to transportation costs. Let's also discuss on-site work and construction time. 2D modules involve more on-site assembly and finishing, which increases construction time. In contrast, 3D modules are plug and play, minimizing on-site labor and dramatically reducing construction time. In terms of module handling and cost, 2D modules are easier to handle due to their lighter weight and smaller size. They are generally more cost-effective because of efficient material usage and lower transport costs. While 3D modules are heavier and costlier to transport, they offer reduced on-site labor costs and economies of scale in large projects. Finally, let's touch on structural integrity and adaptability. 2D modules rely on on-site connections for structural stability, making the quality of assembly crucial. They are also easier to modify or adapt after construction, as individual components can be updated or replaced. In contrast, 3D modules are pre-engineered to be standalone and robust, but their integrated design makes post-construction modifications more challenging. The choice between 2D and 3D modules ultimately depends on the specific requirements of your project. For projects with irregular layouts or unique architectural demands, 2D modules offer unparalleled flexibility and adaptability. They are also ideal for locations with limited access or infrastructure, as their weight and flat design simplify transportation and storage. On the other hand, 3D modules excel in projects with repetitive layouts, where speed and factory-controlled quality are important. These modules are particularly advantageous in locations with robust infrastructure, as they are heavy, plug-and-play modules that significantly reduce on-site construction time. In some cases, a hybrid approach may be the optimal solution, combining the design flexibility of 2D panels with the efficiency of 3D volumetric units. By leveraging the strengths of both methods, it is possible to optimize cost, enhance quality, and improve overall project efficiency. Regardless of the approach chosen, modular construction offers a faster, more efficient, and cost-effective alternative to traditional construction methods. As the industry continues to innovate and grow, modular construction is set to play a pivotal role in shaping the future of the construction sector. Thank you for watching this video. If you liked the overview, you can find it on the TimberTalk Patreon for free. And if you want to learn more about the world of mass timber as a whole, subscribe to this channel.
Stay informed, stay inspired. TimberTalk.